Welcome to today's webinar by the AM Academy. My name is Sven, and today we're visiting OKM3D, a 3D printing company in Mistelbach, Germany. Back in 2017, April to be exact, they published a video on the Raise3D N2 Plus printing this T-Rex skull. The T-Rex skull from Makerbot that is available on thingiverse.com. And this was sort of their long print test that they did with that N2 Plus machine back then. And now we figured we would do the same again. So let me put that one aside. And now we have the Pro3 Plus by Raise3D, and we did the same thing. We printed this dinosaur skull. Made it about as big as we could fit inside the machine. And what ended up happening was that this print took 158 hours. That's almost an entire 7-day work week. The thing weighs more than 1.4 kilograms, meaning because our spools only took 1 kilogram, we had to change the filament midway. In addition to that, there are a couple things that you have to pay attention to when printing for that long. And we're going to go through a number of them as we take a look at not just the printer, but specifically this print. And as I said, all the things you need to note when preparing for a very long-term print. And just so I don't forget anything, I've got a little cheat sheet here in front of me, so don't be surprised if I keep glancing down at what I wrote there. So for this T-Rex skull, as I mentioned, 158 hours of print time, 1.4 kilograms of final weight, and it is just a absolutely massive piece of, well, model. We used the Idea Maker slicing software developed by Raise3D to slice this thing, and we used the speed settings, which means that this model uses a 0.25 millimeter layer height and 15% gyroid infill, plus a raft on the bottom. More on that later on. As I said, we needed to change the spools midway. We'll have a separate webinar just on that topic, but for now, about this skull. Because it is printed from PLA, and because this printer is a closed volume printer with this lid on top, there is something that Raise3D added called the airflow manager. And that's this big thing here inside the printer. And what that does is basically provide external cooling to the internal print volume, allowing it to be about 9 degrees cooler than it would be otherwise, 9 degrees Celsius that is. What this prevents is all the heat from collecting in this top area of the printer, which would cause the PLA filament to soften on the way from the spool to the print head inside the tubes. And when that happens, you will generally get clogs. So this airflow manager prevents that from happening and allows you to have a nice continuous print. Now, why not simply keep the cover off when printing with PLA? If you, as a company, want to be ISO certified, you need a closed build volume at all times. You're not allowed to take off the top cover. That's where the airflow manager comes into play and can be a big benefit. So that was really important to be able to print this from PLA, otherwise it would have most likely failed at some point, especially as our temperatures here in Bavaria were well above 30 degrees over the time that we printed this skull. So that's the airflow manager, but there's a couple things to pay attention to when preparing the printer itself for printing a print that takes over 100 hours. The first of them would be a good calibration of the build plate. Now that's not as much of an issue on the Pro3 because it has a touch sensor, so it auto-calibrates before the print actually starts. But on many other printers, that would be your first step. Then the second step would be to apply glue. Normally on the BuildTech surface, I would say you don't really need any glue, especially not with PLA. But if I'm having a 150-hour print that is absolutely massive, there's a chance that it could fail in the last hour, theoretically. And I don't want to come back after 120 hours and realize that all of that time was wasted. So instead, just apply some glue to the BuildTech surface. We, for example, used a spray glue from 3D Lac, but there's many options out there. All the magic glues and hairsprays and whatever you may want to use. We used this one, it worked great. So that's all I can say about that. Point is just use too much glue rather than too little. Use some glue instead of trying to save the cents that would cost you, because, as I said, you don't want to come back to the printer after 120 hours and realize your print has failed. That would really suck. So That's it for the glue. Then about the filament. Make sure you have enough. I mean, as I said, this took 1.4 kilograms. If we only had a single spool of white PLA remaining, that would not have been enough. So before you start, make sure you have plenty of filament around, whether that is on one spool or multiple spools. As I said, there's the option to change the spools mid-print. And on top of that, depending on what material you use, make sure that it is dry. Either take it directly from the original packaging before starting the print, or make sure it's coming from a filament dry box or a filament dryer to make sure that that is not a negative influence on your final print result. Last but not least, as these are magnetic plates that are held in the printer with magnets, it may be beneficial to use additional clips around the outside for very large prints, such as this one, to prevent the edges from coming up at some point, especially if you have a material that is very prone to warping. So, I don't know, ABS, polycarbonate, something like that. I would generally recommend fixing additional clips to the outside to make sure that the magnets are not the only thing holding the build plate in the printer. So that's it for the printer preparation. And then the slicer, which is basically the last part. This model here was printed completely without support structures because, well, it just works great that way. If you do need support structures for your model, make sure they are stable and not fragile, because once again, it has to print for many, many, many hours. And imagine if I had a very thin column of support material right here, that might have broken off at any point on the way up there. And then, you know, my print is almost guaranteed to fail. So you wouldn't want that to happen. Make sure your supports are solid if you need them. Also, as I said, we printed a raft. The raft provides additional, basically adhesion to the bed, so that's a plus, and it compensates for slight unevenness and bad calibration or leveling of the entire build plate. As I said, not as much of an issue on the Pro 3, but generally for large format prints, the raft is always a good option. IdeaMaker, the software, knows this, and if slicing a model of this size, it recommends you to use the raft when printing. So that's that. And last but not least, I want to mention something about the extruders. If you print a print like this with single extrusion, your chances of success go way up. And if you need supports, use breakaway, because that just allows you to have a much higher chance of success when finishing the print, and it is much faster. However, for some geometries, that is not always possible. And then, you know, as I said, use the second nozzle, but make sure your supports are solid. Make sure you have a solid wipe tower as well that won't tip easily, stuff like that. So it is more challenging with two nozzles, but it does work. You just need to pay extra attention. So that's all I had about this T-Rex skull for today. Thank you very much for watching. If you do have any questions or comments, just write them below, and then I'll hopefully see you the next time around. So see you then.